Let's start with today's topic on sets, relations, and functions. So mostly we will be discussing the concepts of sets. And in general, sets can be thought of an arbitrary collection of objects. It's a very informal way of writing sets, and this collection of objects can in general be anything. So for example, you can also write set as orange, apple, banana, or you can also write a set as some numbers appearing, or you can also have sets which have numbers which are infinite. So the meaning of finite and infinite will be discussed later. So in general, at this point, we can think of sets as collection of objects. And these objects can be coming from certain domain, which will be specific from the particular application. So in general, the sets are expressed in curly braces. But there are other ways of describing sets as well. So if you want to describe sets, there are a few methods which can be used. One is this list notation. The elements of the set are listed. For example, if I write in this form, then it is a set described in list notation. Another notation is called the predicate notation. In which we describe a particular condition that the elements of the set satisfy. So for example, I can write A as set of all x such that x is in between of 1 to 9. This is called a predicate. And we can obviously convert this predicate notation to list notation, in which we are explicitly listing all the elements which are appearing in this set. Third kind of notation is called the recursive notation, in which we describe a set of rules that the set describes. So for example, I can write set of all x such that x is of the form x is an even number. Then this is just a rule that describes this set. And if we try to write this set in the list notation, then it's a list which is uh, an infinite list consisting of all the even numbers. So these are some basic ways of representing sets, and along with that we need to understand some of the notations used while we are dealing with sets. So if you want to write particular element, if x is an element of set A, or if I say x belongs to set A, then we can write this as this notation. X element of set A, the meaning of this x is an element of the set. And if you want to write the converse, not, then I have to write x is not an element of set A. So these are some basic notations, and another notion um, is the concept of a subset. We say that B is a subset of A, which we write as B is subset of A if all elements of B are in B. But if you write it in more mathematical terms, then the meaning of B subset equal to A is for all x in B, x is also subset equal to A, meaning is B is either a strict subset of A or B can be equal to A. B not subset of A means B is not a subset of A. And B not a subset of A, and B is also not equal to A. Based on this, we can take some example. So if we have A equal to then B is not a subset of A here. And I will take another example is x such that it's an even number and B is 6, 8, 10. Then clearly B is a subset of A. And obviously B is not equal to A. So this is the concept of a subset, and using this subset condition, we can also check whether two sets are equal or not. So two sets A and B are equal if and only if A is a subset of B and B is a subset of B. If this condition holds, then this holds. If this condition holds, then this holds. So this is one way of proving equality of sets. If you can prove both these conditions, then automatically this condition is proven. Also, there is this concept of null set, which is phi, which is basically doesn't contain anything. And null set is always a subset of any set A. So if I want to have an example, if I'm asked to find all subsets of this set, then all the subsets are null set 1, 2, 3, 1, 2, 2, 3, 3, 1, and 1, 2, 3. So this set of all subsets is also called the power set. Also, it can be written like this. So associated with the set A, we also need to have a concept of number of elements in a set A, or I can say cardinality. That is written as this, which is equal to number of elements in the set A. So for example, mod of A will be equal to 3 if A is equal to then have cardinality of 2 to the power A is equal to 2 to the power cardinality. So these are some examples which show how the number of elements of a particular set is simply the Number of is simply the cardinality of x. So based on these basic concepts, we can define some operations on sets. The operation on sets are simply taking two sets and applying an operator on them. So I will discuss a few operations. We can define what is called the union of two sets, the intersection of two sets, complement of a set, subtraction of two sets. These elements, these are some basic operations uh, which, are, which can be applied on sets. And let me define each of them one by one. So one is simply A union B is the set of all elements x and that x is in A or x is in B. A intersection B, x is such that x is in A and x is in B. A complement is simply set of all x such that x is not in A. So in this, there is an assumption that all the elements of A belong to one universal set called U. So when I write something like x is not in A, the meaning of this is x is not in A and x is in U. So in this case, we have to take in mind that all the elements are coming from some universal set U, and we have to take all the elements which are not in A and present in U. And A minus B is simply set of one x such that x in A and x is not in B. So these are some basic operations which uh, can be applied on sets. And after this, we will discuss some properties of these operations.